Well, welcome back to the shop, everyone. Today's project, should you choose to watch it, is lockable hinges for air traffic control console keyboards. This is something I did a couple of years ago, and the problem with these things was the hinges were breaking. These are old units, and they replaced the consoles, but elected to keep the keyboard trays because they couldn't get the specs in the new units. And these are 30 to 40 years old. Originally they had the multi-steel leaf design here, which worked okay for the keyboard section, but where it connects to the console, they were tending to break over time. The main problem was that the controllers were not loosening the lock bar enough to adjust it and then retighten. So they had them welded at several different places over the years, and they didn't last because of the type of steel. I guess it would harden and crack. So I designed and made for them a couple of years ago these aluminum multi-part hinges for both sides, and after 2 years we're back to the original problem. The guys just don't loosen the clamp enough, and they tend to gall these pieces and wear them so that they don't lock anymore. So what we're going to do is make them a new set from steel. These are the original sketches I did a couple of years ago, and we've got our 8 pieces cut and laid out on there and numbered so we don't get them mixed up. Pairs of parts have the same but opposite cuts, so we pair them up and machine them in pairs for the most part. And I'll show you each bit of the operation so you get to see how it all goes together. So first things first, with these pieces of flat bar, we're going to face off the ends of them, try to get them a bit even. So the next step in our hinge brackets, our hinge pieces, is to mill each piece halfway through. They're all done the same, so we set up a vice stop to get their length the same on them all, and we'll set it up and do all that particular cut at one time. Then we'll set up to do the next operation. So according to our plan, we need 2.5 from the back end up to our shoulder here. Right now we're on 2,635. Okay, 4 more. Just to get it exact. Hello, little man. What's on the go? Get a pair of glasses over there, can I? Okay. So now that we have our assistant with us, we've got our first piece set up, vice stop to get our 2.5. Cutter height is set, so we'll just go and plow through the other 6 or the other 5, and away we go. So So the first step of the operation is complete. We got all our 8 pieces essentially split in half so that when they fit together it forms the locking joint. So next we'll set up and do some of the other cuts. We have to cut some relief over here for a cross member, and we have to cut off the thickness of the original steel frame so that it sandwiches the frame and makes a rigid assembly. So in this step now we get to cut clearance for the cross member in L2 and right 2. So we'll pair those up and get them in a vise, which we've already got done. And we'll touch off, drop it down the required 400 thousandths, and we'll make our cutout 1 inch and 60 thousandths. Try putting it in gear. Okay, let's get set up for the next pair of parts. Okay, so for the next step we take the pair of L3 and right 3 and we cut a small corner off each one to fit inside the original rectangular tubing. It's going to be 150 deep, 1.25 inches long. So that's those 2 pieces ready to be deburred. So that's R3 and L3. Let's go on to the next step. L4 and R4 need a small cutout in the back of those. It's only going to be 350 long and the same depth of 150 as before. Now pieces L1 and R1 will be done in a similar setup, and the number 2s will be done in a different setup because the cut is a different length. But we can only do these one at a time. We have to thin, where are we to here? See if you can see this. So we have to thin each piece down by the thickness of the original tubing wall thickness, and which is 60 thou. So we got L1 set up in the vise there now, so we'll get that one done and we'll move on to R1. Okay, let's switch out to R1. We got a mess of cutting oil on this shiny new mill. I don't know about that. Okay, so that's R1. Now I'll get set up and do the number 2s. R and L2 are the same, only the length only goes to 2 inches rather than 2.3. There's our 2 inches that way. Square it off a bit. And we'll get the next guy in there. So this is about it for the milling part of this. Next thing we'll get set up to do is drill all the holes, and then we'll final step will be to radius the ends. So to do the hole drilling, again we pair up like pieces and stack them in here, and actually we won't, because that's gonna stay tight. Ah. Okay. So to start off with the hole drilling, we'll do each piece individually. We're going to align with the end of the vise, move in our required 3 inches. We'll center up here and start drilling. Halfway. repeat, like Ox Tool says. Okay, so I blew through all the drilling, and well, I didn't bother to put the camera on. I mean, once you've seen a hole drilled, they're all the same. It wasn't that exciting. You're allowed to trust me on that. But I will bring you back when we set up the rotary table, do the radius on the ends. Okay, so now that we have all our thicknesses cut and holes drilled, the last step in this procedure is to put a radius on the end of these so that they will turn together as a hinge. Use the rotary table, of course. I've got a slug cut that fits the bore in the table, and we're going to bolt these to this slug and run an end mill around the end and do a nice 1/2 inch radius. First things first, we'll center up our table, and what I use to do this is simply a cone cut held in a collet. Bring it down. You don't even need to tighten the collet for this, and wiggle everything in place and use your spindle to line it up. And if my arm is not in the way, you'll see. Snug your table down there, and then you can use your indicator to fine-tune it from there. It's about as quick and painless as you can make it, I guess. Works for me. So next we'll put our adapter piece in our table. Okay, now we dial in our 1/2 inch radius. We get a 0 set over here. So there's a 1/2 inch. We'll lock down our table and our knee here. The rest of it is simply crank these around. We're going to eyeball these in roughly square with the table. Snug them down good. We got our quill preset to a depth there. So we'll start it up and get going. And of course the phone rings. We got dumped on last night for sure. We got lots of snow to worry about. It's a piece of a tractor there if I had the rest of it assembled. So here's how it sits so far. We got most of it back together. We got the fuel tank in, hydraulic pump on. Just waiting on fenders and stuff. Alright guys, we're calling this one got her done. We gotta go out and clear some snow. See you in the next video. So here's a little update on the console hinges. We got our pieces pretty much made. The original unit had a rod coming through here with what amounted to be a small piece of flat bar with a dimple, and relied on friction here to lock the unit. And it was always a problem with the handle not locking the tables down tightly. So what we've made up this time is a locking piece that will actually fit over our hinges, and it locks solid. So when we get this welded onto here, there should never be a problem anymore with that aspect of it. So once it's tightened on this handle here, the unit remains pretty rigid actually, and we get a full 180 degrees of movement here. So I guess all that's left now is to weld the rod to the lock plate, paint, powder coat, and chrome, I guess. We'll call it like a motorcycle. And bring it out to our customer and start on 10 more like it. So this is our completed assembly for the keyboard trays. How we got it geared up, of course, the two back pieces mount into the console itself with a couple of bolts. So all the controller has to do is loosen this handle, and he gets a full 180 degree pivot of these hinges, so he can use it from a standing or seated position. And when he gets his tray to the height he wants, you just turn this handle. It's resettable here because there's not a lot of clearance over top, and you tighten this down and you have it locked very securely. So if you're flying anywhere from probably Maine up to mid-Atlantic, your flight is being controlled by a controller sitting at one of these keyboard trays. There are 10 consoles out there, and I guess at any one given time there are several controllers on duty, and one of them is looking after your plane. Thanks.